Okay, in this video I'll be going over the test for review. I'm guessing there's going to be about 2 or 3 videos here. So in number 1 here it says determine if the following functions are one-to-one. Now we know that a function's one-to-one if its graph passes the horizontal line test. And so if you look at a, f of x equals 3x cubed minus 2, we know that the parent function is x cubed, and because of the 3, this one is going to have a vertical stretch, and because of the minus 2, it'll be down 2. So it'll look something like this, and you can see that would pass the horizontal line test if you were to draw horizontal lines. There's no place where you can go through more than one point. And so yes, that is a one-to-one function. On B, we have f of x equals the absolute value of x minus 4 plus 2. And if you graph that, we know that's V-shaped, but we're going to have a shift 4 right and up 2. And so it'll look like that. And you can see that doesn't pass the horizontal line test, so the answer here is no. On letter C, I would probably just put this one into a calculator, and you get a graph that looks something like that. And you can see that doesn't pass the horizontal line test either, and so the answer is no. All right, on number 2, we're supposed to confirm that each function is one-to-one, and then find the inverse. So on the first one here, if you graph this, this is a linear function, and the y-intercept is 0, negative 2. And if you apply a slope of 5, go up 5 and right 1, you're going to have this line. And in fact, every line except for a vertical line is going to be, I should say every line except vertical or horizontal line would be a function that's one-to-one. But in this case, you can certainly see this passes the horizontal line test. Now there's 4 steps that we discussed about how we're going to find an inverse. So first we're going to replace f of x with y. So basically we're just changing to the y notation because it's easier to work with when we're basically manipulating an equation. And then we'll switch our x and y's, so that's a really important step when we're finding an inverse. And then the other important step would be now we solve for y. So we're going to add 2 on both sides. We get x plus 2 is equal to 5y. And to get y by itself, we need to divide by 5. And so we get y is equal to x plus 2 all over 5. I'm not going to write that separately. I'm just going to go ahead and replace y with f inverse of x equals x plus 2 over 5. And that is our inverse. All right, on B, we have g of x is equal to the cube root of the quantity x plus 4. And so in this case, when you graph this, we know that the cube root function, it actually looks a lot like y equals x cubed, except it goes to the side, or it's sideways. It looks like this. Notice we have a shift 4 to the left here. And you can see that that would pass the horizontal line test. And so we've confirmed that this is one-to-one. Let's go ahead and find the inverse. So we'll switch to the y notation and then switch our x's and y's. And now I need to get y by itself. Before I can mess with that plus 4, I'm going to have to get rid of that cube root. The opposite of taking a cube root is cubing. And so we're going to cube both sides. So we get x cubed is equal to y plus 4. And now we can subtract 4. And we get y is equal to x cubed minus 4. And the only thing left to do is to write that as g inverse of x is equal to x cubed minus 4. All right, on C, it'd probably take a little bit of time to graph that one. I mean, you'd start by finding the vertical and horizontal intercepts, or asymptotes, and then find a few points. I'm just going to go ahead and put the graph up here. I mean, you could also put this into your calculator knowing what you do about the asymptotes and just finding a few points, and you would see that the graph looks something like this. And so you can see that that does pass the horizontal line test. And so it is 1 to 1. So let's go ahead and do the 4 steps now. We'll write y equals x plus 2 over x minus 3. And let's switch our x's and y's. Notice we have 2 x's that are going to become y's. Now, at this point, there's a lot of algebra left to do to get y by itself. Notice it's in the numerator and denominator of this fraction, and that's our problem. So anytime we have fractions in an equation, we normally want to clear the fractions first, and that's what we're going to do here by multiplying both sides by y minus 3. And so on the left, we'll distribute. We get xy minus 3x. On the right side, the y minus 3's are going to cancel, and you get y plus 2. Now, as I look at this, I see 2 terms that have y in them. I need those on the same side. So now you could probably do this in 1 step, but I'm going to take it in 2. So first, I'm going to add 3x to both sides, and then I'm going to subtract y on both sides. And now I have my 2 terms with y on the left, and so I'm getting pretty close now. At this point, hopefully you recognize that you can factor out a y. And so this would be y times x minus 1 is equal to 3x plus 2. And finally, since we have x minus 1 times y, by dividing both sides by x minus 1, we get y by itself. So we're going to get y equals 3x plus 2 all over x minus 1. And the only thing left to do is change to the inverse notation. We get h inverse of x is equal to 3x plus 2 all over x minus 1. Now in part D, it says to find the domain and range for h of x, and its inverse, and that's the one that we just did. So I'm going to go ahead and move this graph down here, and you can see that for the domain, this graph goes forever left, and then it goes to the right, and it gets to where x is 3, and there's a vertical asymptote. And so we have a break at 3, and then the graph will continue on to from left to right. And so the only value that's not included in our domain is 3, and again, that's where our vertical asymptote is. So negative infinity to 3 union 3 to infinity is going to be our domain. And by the way, I put f of x on these. These should say h of x. I just realized that. So let me just do that real quick. And one more. Okay, so we know that the domain of h will be the range of the inverse. We know that the domain and range will be flipped for a function and its inverse. Okay, so let's go ahead and look at the range now, going from the lowest to the highest point on this graph. This does go down forever, and then it goes up until it gets to 1, and then there's a break. So it'll be negative infinity to 1, and then you can see to the right and up, it goes from 1, and then it goes up forever, so that would be 1 to infinity. So our domain is negative infinity to 1, union 1 to infinity with parentheses. And our domain of the inverse would be the same. All right, let's move on to the next slide. So on number 3, it says for the function f, use the composition of functions to show that f inverse is as given. State your conclusion as a complete sentence. So basically what we're being asked to do is compose the function with its inverse. So basically f of f inverse of x, and and to see that that equals x. Notice in this case, our input and our output would be the same. What that really means is when you run the functions back to back, the second function undoes the original. You start with an input of x, you get some other output, you plug that into the other function, and you get back to x. And so that's the idea of inverse functions. They undo one another. And similarly, it has to work in the other order. And so that's what we have to do here, is show that in both cases we're going to get x as our output. So finding f of f inverse of x, we know this is f of f inverse of x by definition. And so f inverse of x is our input for the f function. It's x minus 8 over 5. And so that's what we're plugging into the f function. Now what does the f function do? Well, it multiplies your input by 5 and adds 8. And so that's what we're going to do here. I'll make a shell. So 5 times my input plus 8. And so let's plug in our input. You can see the 5's cancel here. You get x minus 8 plus 8, and you do get x. And let's do the same thing for f inverse of f of x. So again, by definition, this is f inverse of f of x. F of x is 5x plus 8. So we're plugging one function into the other. And so now the inverse function takes our input and subtracts 8, and then all of that's divided by 5. And so again, I'll make a shell for the function, and I'll plug in our input. Now we can drop the parentheses here, and 8 minus 8, of course, is 0. We get 5x over 5, which simplifies to x. So we just showed that these are inverses. And so it says state your conclusion as a complete sentence. I'll go ahead and show you what I wrote here. The composition of f and f inverse is equal to x in both directions, which shows that they are inverses. And so that's the idea. All right, let's move on to number 4. It says graph each function by finding 3 points, which is what we did in class, or what I did in the videos for those graphing sections where we did some graphing. So let's go ahead and I'll remind you how we do these. So the first thing I would do when I graph f of x is equal to 3 to the x, first of all, I know that's an exponential function. So I know exponential functions that have a base greater than 1 are going to go through 1, 0, and we're going to have exponential growth with an asymptote here. And so hopefully you already have a feel for what this graph's going to look like, and we just need to get 3 detailed points. And so